11 waiting. Let's go.
Yeah, we are live.
Awesome. Hello, everyone. Good morning and a very warm welcome to Serverless Saturdays for the edition of April. So I'm Srishit Pakula. I work as head of engineering at Confirm. I'm an AWS serverless hero and I love to talk about serverless. Karthik?
Yeah, as Sushit said, hey everyone, welcome to Serverless Saturdays. We are super stoked to host this eighth version of Serverless Saturdays, and I am a community manager here. And Sushit, as he told you, he's a serverless hero, and we have this initiative where we bring you latest and the best experts in cloud and serverless. So, without any further delay, Sushit, would you like to take it further?
Sure, sure. Thank you, Karthik. So can we have the poster up, please?
Sure.
Okay. So, as always, we have a couple of very interesting sessions lined up today. And with the world of serverless, people predominantly would have worked with Lambdas, API gateways, DynamoDB, and pretty much of those lines. But the world of serverless on AWS is like an ocean, right? We have so many other services available, and talking about a couple of such services which are kind of important when you're building serverless applications is one is Introduction to AWS Step Functions by Bennett from Serverless Guru, and we also have Jones from Mobile AT Solutions, who will be talking about building APIs with AppSync. Both of these services are very close to me. I've worked with both of them pretty extensively as well. And for people who have not already explored these services, they certainly should go ahead and explore them. They have some really good capabilities, and I'm sure the speakers are going to talk more about it, and they'll just get you started with these services. And as we have also already put up on the meetup page, we will have a quiz towards the end of the session. So request everybody to stay back, and you top the quiz, you get a chance to win a $50 AWS credit from us. So please do stay back and play the quiz. So we will be sharing the link to the quiz in the chat section. So we would recommend you to go ahead and register on the platform so that there'll not be any hiccups during the quiz session. Yeah, so Karthik has already posted the link. So without further ado, let's have Jones on the stage, please.
Hey, Jones. Uh, am I audible, Jones?
You're on mute.
Yeah, you're on mute, Jones.
Hi Karthik, hi Sushit.
Hello, Jones. How are
Yeah,
you doing?
I'm good, thank you. How are you guys doing?
Doing good.
awesome. We are super stoked to have you, Jones. Uh, and would you like to give a brief introduction about yourself and the talk that you are going to present today?
Okay. I'm Jones Zikra Noel. I'm an AWS community builder and also a cloud architect for serverless at Mobility Solutions. So today I'll be speaking about building serverless APIs with AppSync. So AppSync being so AppSync being yeah. So um, so back to about me. I'm also a serverless advocate. You would see me speaking about a lot of AWS serverless services, and also I write a lot of blog posts on dev too, with the serverless how tos and different architectures. Also, I'm a hobbyist photographer and a baker. So the agenda for this session is learning about GraphQL, how it's been structured, and also what is AppSync as a service. And we'll have an introduction to AppSync and why would we choose AppSync, and also we'll be understanding VTL, which is one of the primary component of AppSync and the resolvers behind different queries and mutations and different objects. We'll also have a demo with Amplify CLI to deploy a, AppSync based API. So coming to GraphQL, GraphQL is an open source API, which open source data query API, which helps for building APIs with different manipulation language, and also it is backed by Facebook, where you define your complete schema, and based on the schema, we'll be defining different queries to get the data from the data source. We'll be writing mutations for updating, creating, or any data changes to the data source, and subscriptions for real-time updates, where we'll be getting all the data whenever there's a change in data in any of the data source. And if the client was subscribed, we'll be getting the update to the client itself. So with GraphQL, from coming from a typical REST API based APIs, what you do is whenever you make a request, you get all the parameters, whatever the server or the backend is returning. But with GraphQL, you have the feasibility to request for the things that you only need, and you get only what you ask for. So imagine you're at a restaurant, and you go and you ask for a plate of a burger, and you get a pizza also. So that's not what you expect. But when you are asking for a specific burger with a specific fries, and you're getting the same thing, you would be happy. So GraphQL is something of that sort, where you get what you ask for. And also building with different complex models. So GraphQL has a predefined schema. So you know that there's a specific type or the specific object that is coming in as a response, or you're sending in as an input. So your schema for your APIs, both request and the response, is very well defined, with its data types being predefined, so that you know that, okay, I'm sending an integer type, or I'm expected to receive a string type. All that is predefined, so making it more friendly for API integrations on the front end. So what is AppSync? AppSync is based on the GraphQL service itself. So AWS is providing us with a managed serverless GraphQL service, which is AppSync. It has a seamless integration with services such as DynamoDB, Lambda functions, OpenSearch, and various other services, where you can easily integrate for requesting and writing data into that data source. It has a seamless integration for authentication with Cognito pools, Cognito user pool, and identity pools. You can even have API keys for a specific use case. Lambda authorizers is something that where you can define your own authentication, and you can build your own authentication based on Lambda authorizers. So making you or giving you the feasibility to choose what type of an authentication you would choose for your APIs. So AppSync also recently launched custom domains. So currently what they're doing is it's using a CloudFront based domain, but once you go with a cloud custom domain, you can even choose your specific domain, so that all your GraphQL endpoints are with a specific domain itself. When you're working with a lot of mobile applications or front end applications, offline storage or offline caching is one of the key features, and AppSync provides it, where it's able to cache the data locally on the client, and even the caching is available on the server side. All the APIs, since you're working with a single GraphQL endpoint, all the APIs have a single endpoint itself, not like the rest APIs, where you could have multiple endpoints or different paths for your resources. This is always going to be one single endpoint, but it's going to have a lot of queries and mutations that's there. So how does this all work? Uh, so this is a diagram from AppSync uh, AWS AWS page, and here we can see the diagram itself, where it's mentioning there are different use cases to it, where it could be enterprise applications, front-end mobile applications, or IoT devices, which is requesting or writing data via AppSync. So AppSync has different resolvers based on the GraphQL schema, and this resolvers can connect with DynamoDB, Amazon Aurora. It can even connect with Elasticsearch, which is open search route, and also Lambda functions, and it could even connect to an open HTTP endpoint. So suppose if you have a query that you have to do with a specific open HTTP API, you could even do that with AppSync. So all the AppSync queries and mutations are easily monitored with CloudWatch, and it has a seamless integration. So you wouldn't have to worry about logging all your APIs or checking, or which helps in a lot of debug cases. Whenever there's a request that's made from the front end app or from an IoT device that's there, AppSync uses uh, the GraphQL schema for identifying which query or which mutation it is. And based on the mutation or the query that is there, it understands the resolver that's there. And based on the resolver, a resolver is nothing but the VTL that's used under the hood. And VTL helps in transforming the request to the data source. And once the data source returns back the response, it transforms the response to the way how AppSync requires, and it returns the complete response from AppSync to the client, making it a easier way for all your API request responses. When we're speaking about AppSync schema is based out of a JSON object where it contains things like queries, mutations. It could even have subscriptions and a different input objects, type objects, enums, and directives. Whenever we are working with something that's getting data, it's queries. Whenever there's a change in data, it's mutations. Whenever there's a real-time update of data, it's subscriptions. And for all the inputs, we can even specify input objects, making it more structured for us to create complex inputs. And using these input objects, we could even make sure that the inputs are validated according to what is mandatory, what is optional, and also the different type of the data. And coming to enums, AppSync supports enumerated data types. So that, say for example, you have things like statuses, or things like for statuses, for example, you have something like active, inactive. You wouldn't have to consider them as string values or anything where you were expecting it to be an input where the client can send it as totally uppercase or lowercase, or the whole case becomes a scenario where the server expects one, the front end expects one, making a mismatch in things. So enums or enumerated types helps in making sure that these kind of values have a enumerated value itself. So active is one, active as a word itself is one value that's common and that's acceptable by both the server and the front end. When we're saying AppSync, and why would we choose AppSync? So AppSync being GraphQL servers, it's easier to integrate with frontend. Uh, the reason being, uh, you can request for what you want, and also you have the schema that's already predefined. So if the schema is wrong, AppSync helps in pre-flight validation of inputs and responses, so that it validates against the input object that I was mentioning earlier, and also the type of the object, type of the response that's returning. And these things are validated at AppSync level, so you wouldn't have to worry about having a validation return in your business logic, or in a VTL resolver where you're checking, okay, is this parameter coming or not, and is this parameter of this type. You wouldn't have to worry about these sanitation problems, whereas AppSync takes care about it for you. As I was mentioning, the integration of AppSync with different queries, mutations, and different type objects is seamless with different AWS services, so making it easier for developers to integrate with the commonly used services such as DynamoDB or Lambda function, making it a easier way. And also you wouldn't have to go through Lambda for all the things. because directly with the VTL resolver, you can interact with DynamoDB. Also, the authentication part of it, since AppSync supports Cognito usable as authentication type, what we would have to do is we can create users and groups on Cognito itself, and we can take care about managing the users based on the groups and based on the permissions they have. And also, AppSync provides a auth directive, which helps in defining what type of user has permission to what, and also ensuring that the APIs are access controlled based on the user itself. And of course, all the real-time subscriptions are powered by WebSockets and MQTT. So the connection, the connection that's there between the client and the server is maintained by AppSync itself. So you wouldn't have to worry about what if my WebSocket is disconnected? What if my MQTT connection was disconnected? You wouldn't have to worry about it. Instead, the AppSync SDK itself on the front end helps in maintaining these connections. And the subscriptions are very powerful, where you can there are applications such as chat, there is applications that is real-time updates, like a monitoring system or anything that's been built on AppSync subscriptions, which is really powerful and helps in building a lot of real-time systems. The performance, of course, GraphQL being one of the powerful ways of API integrations, the performance over REST APIs is much better. So you wouldn't whenever you're working with REST APIs, you would have had a lot of difficulties, and the challenges. All these are also overcome by AppSync, making it the one of the preferred choices for front-end mobile and web applications to choose AppSync. And all the APIs are also secured with WAF. So whenever you have APIs, you can secure them with WAF. I'll probably show you in the console how to enable WAF and uh, enabling and ensuring that your APIs are secure. So when we are working with AppSync, VTL is one of the primary components, because all the resolvers that's there to the different data sources, or it could be a single resolver or pipeline resolvers, all these things are using VTL under the hood, VTL, and this VTL is powered by Java. VTL is nothing but velocity template language. The VTL itself is a way of ensuring that there's a mapping between REST request and response. So this helps in transforming data from the AppSync API itself to the data source, and vice versa also. There are different type of VTL resolvers, one being unit resolvers, so where there's only a single data source that the API is interacting with. Whereas for pipeline resolvers, you can create multiple functions so that each function is speaking to a dedicated data source, making pipeline resolvers one of the powerful way to talk to multiple data sources, and uh, and combining the data and ensuring that you have everything in one go. This is one of the sample VTL resolvers for DynamoDB, and this is using a put object where we're even transposing the inputs that is coming with arguments to a DynamoDB JSON, so that it's always in a marshaled JSON way. With VTL, you have certain intrinsic function or utility helper functions, which helps in making your VTL resolvers powerful. Some of them are things like parsing JSON and string, and vice versa, and things like generating unique IDs. So you have something like auto ID and ULID, which helps in create unique IDs. And also, these are something that can be created during the resolver time, so you wouldn't have to worry about creating them on the server or something that's been sent as a parameter. Whenever working with the server side, you have to create a lot of timestamp based values. So these support also ISO and epoch based times, and these are created on the fly with these util helper functions. whenever working with DynamoDB being one of the famous or most preferred data source on AppSync, uh, it has an exclusive helper for DynamoDB based APIs where you can transpose the inputs into DynamoDB JSON, or you could map them to a map all the values to a JSON based structure. You can work with a lot of lists and also maps also as well. So when we are working with AppSync based APIs, there's different ways of creating your AppSync and deploying it to the cloud. Whenever we could do the simplest way of doing it is from the AWS console, where we can create the AppSync based API and also enable or add different data sources that's there. The other one being Amplify CLI, where Amplify CLI enables us to create Amplify CLI being the front end and web application. It helps front end developers build full stack applications, and also you wouldn't have to worry about creating a lot of resolvers that I was mentioning about VTL and all those things. You wouldn't have to worry because the Amplify CLI itself will create these under the hood, and you can even modify them and edit them. uh, SAM or serverless application model, that is another way, and CDK is also another option where you can create your AppSync APIs. So for the demo, we'll be looking into AppSync API with AWS Amplify CLI. So let's jump into the demo. So this is an empty folder that we have, and I'll be using Amplify CLI, which is pre-installed, and also I have my user that is being set up. So I'll do Amplify init. This is initializing the project, and that's under the hood provisioning the backend service also for Amplify. So we'll go with the default settings, since this folder, this directory doesn't have any front-end based application. The JavaScript framework is none, and also we wouldn't have a build or a start command that's there. I'll go with AWS profile. You can see that once I choose the profile, it's provisioning the backend environment on Amplify. Under the hood, it's still using CloudFormation, where you can see that all the IAM roles, S3 bucket have been created, and it's in progress. So probably if while this is being provisioning, if there's any questions we could take. And so the Amplify project has been initialized, and the next step being we will be using an AppSync API, which is authorized by our Cognito user pool. So we'll be creating authentication with Amplify add auth. So we go with the default configurations, with the sign-in being username, and this should do for it. So with Amplify add auth, under the hood, Amplify CLI is provisioning a Cognito user pool. So Amplify add API is another way of creating GraphQL or AppSync APIs from the Amplify CLI. So here we can see that it provides two options, GraphQL and REST. We'll be going with GraphQL. We can see that it auto-populated or it's recommending certain authentication modes. So we'll just go and modify the authorization type for our API from API key to Cognito pool. We'll say no and continue. So whenever we are working with Amplify CLI, it provides certain samples or certain schema templates for us to get started with. Uh, it could be with single object or one-to-many object and objects with fine-grained access. So we go with this so that this also covers the Cognito user group based permission handling. So it has created a schema. We'll not edit it at the moment. Once we added this, you can see it created certain uh, directories and files and folders here where you can go to. So under the backend directory API, you can see the complete model has been. Yeah. So you can see the complete schema has been created where it's having different type objects, a different input that's mentioned, and also there's various enums that we have added that the template is provisioned with. And when we are working with queries, you can see that there is a certain query which is using inputs. It is using input objects as filters, and also for pagination, it's using limit and next token. For responses, there's different type that's been defined. The same with mutations also, and there's subscriptions that's also been created from the template. When we're working with resolvers, you can see that the template has auto-created certain VTL-based resolvers, and these are pipeline-based resolvers. Uh, you can see for one of the mutation create private node, there's one function which is checking the authorization and also yeah. So it's using the context and identity object, which is checking for the user's name, the username from Cognito itself. It's also checking for who's the owner if it's not null, and there's certain other validations that's being done. You can even see, for example, create task auth. We are using certain Cognito user groups with the name managers, and these are anybody who's part of the managers group has access to the specific mutation. All these things is auto created from the template itself. So the next step being amplify push. So now that we have created our Amplify Auth, Cognito Usable, Amplify API, AppSync based APIs. The next step is deploying them to the cloud. So Amplify Push uses CloudFormation in the background, and so it uses CloudFormation in the background where it's creating a CloudFormation stack and uploads them step by step to the cloud. So this would take a couple of minutes. If there's any questions or anything, we could take them at this time. Karthik, Sushit, any questions that we could answer?
Hey Jones.
Yes, Karthik. So any questions or anything that we could answer while this is being provisioned?
Hey Jones, thank you for the great start. So yes, I think there are a few questions.
Mhm.
The first, I mean, one of the questions, I'm sure you would have expected this. VTL versus Lambda resolvers. So
Yes. So
I think
personally, not a fan of ETL.
I mean, any app sync session, I don't think goes without this question of people. So yeah, one of the questions is, I mean, not exactly a question, but one of the concerns is about VTL, the learning curve, and everything. So, any tips and tricks that you want to share with the audience?
Okay. So not exactly tricks, but certainly some tips and some beginning starting points where you could learn how VTL works, because under the hood it's all Java, so it's not something rocket science. But again, for new developers, it's hard for them to get started with VTL, uh, because one of the difficult ways is it's hard to debug, right? Uh, so whenever we are working with certain things like DynamoDB resolvers, VTL is a good choice. But if you have some complex, very complex business logic, Lambda is my preferred choice, because it gives you a feasibility of choosing your own language, which you're familiar with, to write your business logic and the complete thing there. Whereas VTL, you have you're bound to follow certain VTL rules, VTL uh, schema, VTL syntax, all of these things, which for somebody who's beginning, it's hard to follow on to, right? And also, I guess Benoit has one of has a debugging tool for VTL mapping tool. So yeah, he's mentioned that in the chat. I mean, it's
Yeah, thanks for that. I mean, I was actually searching for that tool link. Thank you for sharing.
Yep. So as you can see in the screen, you can see that when I'm trying to push with Amplify, it's mentioning what are the resources that has to be pushed, and I'll just confirm telling it's auth and API, and we'll not create API keys. Yeah. So, Sushit, any other questions around VTL or anything specific for AppSync? I
Yes,
see Michael shouting out for AppSync subscriptions. Yes.
yes, we do have one question. Let me bring it up on the screen. Karthik, can you have that question please on the screen?
Sure.
The last but one from Michael. VTL is hard. Okay, yeah, here we go. VTL is hard to debug. So, what is your advice? Unit testing VTL integrations. Yes, this was also one of my questions I was going to ask towards the end, but here we go.
Yeah. So when we're doing unit testing, so unit testing with unit resolvers, I mean, the level of difficulty to debug is slightly easier, but it's again not my preferred choice with going with VTL, because it's hard for debugging. I mean, like all of us know who has worked with AppSync, right? So one of the ways is the mapping tool itself, where we can, I mean, at least as a beginning point, it's good for us to debug. Otherwise, Sushit, any other suggestions, or not any suggestions or anything with respect to debugging VTL?
Yeah, I think with serverless applications, this is kind of a problem that a lot of people face, like local testing, unit testing. Given that in serverless applications is generally about stitching multiple pieces together, right? You have multiple AWS services and everything, and certainly VTL is relatively difficult to debug. But yes, like what a lot of people in the world of serverless talk about, don't test anything locally, just push it, have a dev environment, do your testing there, don't do anything local. And coming to the specific question of unit testing, frankly, even I've not been able to really crack that as such yet. I don't really think uh, there's so much available again. But with Amplify, one of the advantages is we have that Amplify mock, so we can do a lot of testing. But again, unit testing is something that even I'm exploring. But even I don't really have a great answer for that.
Yep. So unit testing, maybe things like testing the logic locally, it's fine. But as you mentioned, integration is best with the cloud itself, right?
Right. Exactly. Exactly. Integration in the world of software, not just VTL, right? We have so many other things.
Correct.
So integration testing on the cloud is always the preferred option. So another interesting question, which again I also had, so but the audience are giving it out themselves. So uh, has anybody tried? So one of the questions from Easy Cloud Computing is: did anyone ever dare to use AppSync without Amplify?
Uh, okay, that's a tough one because Amplify gives you a very easy way of integrating with your front end application. So I'm not sure. I haven't used AppSync without Amplify, but I'm not sure if somebody has, and what's their experience. So I'm not sure about that.
Right. I used it for one of the projects. I mean, long time back. Uh, um, yeah, I mean, a few years back, and I mean, yeah, Amplify using it with Amplify has a lot of more advantages, is what I would say, rather than using it directly, where you have to write your resolvers. And I mean, of course, here also you'll have to, but Amplify gives you that kind of an environment where it's much more easier to do it. Okay, we have one more question.
Okay. So in terms of storing data, you can choose between things like DynamoDB, which is one of the preferred choices with AppSync, right? The other one being RDS, also where it has a good RDS, and Aurora, where it has a good integration from AppSync to store, read and write data from your database. So the two options would be Aurora and DynamoDB for storing data. Oh, I see some comment from Richard telling that he only uses AppSync without Amplify. So that's some unique thing. So I see something about single table design on DynamoDB as well, where Karthik is using Lambda-based resolvers for all his queries and mutation.
Okay, so I have one more very generic question. So when should one choose AppSync over REST APIs? Is there any kind of guidelines or principles?
Okay, so one of the things why you would choose AppSync is the schema that it provides, right? With REST APIs, you wouldn't have that, but if you're thinking about choosing REST APIs with different resolvers or different integrations to the cloud. So, say for example, you have a REST API which is posting something to SQSQ or something. REST API is the way to go. And also, when you're working with uh, clients that don't use a session-based authentication, or things like a system which is posting data like webhooks or something, that's probably a choice of API gateway is a choice that you would have. Otherwise, AppSync should be. I mean, uh, there is a lot of debate over AppSync versus API gateway, right? Where uh, the most opinions are AppSync helps with good integration with uh, front end applications where you're thinking about creating a new mutation where you would have to do a put or a post with REST API. You could do it with mutation, and also there is a schema validation that's there. So there is models on API gateway, but the way how AppSync handles validations is much more easier and much more simpler for developers to begin with. So yeah.
We
So I
have
think
a
Richard
one more
is.
question.
Yep. So how I'm monitoring and observing with AppSync. Okay, so as I was mentioning, AppSync has a good way of integrating with CloudWatch. So all your logs are available as CloudWatch log groups, and for you to view at them, it's easier to point out to a specific API ID or API ID is what AppSync calls it. So the group is created with that, and you have a lot of logs coming in with the request and response, so you can view them. Unfortunately, VTL based logs are not available there. That's what makes VTL hard in terms of debugging. Uh, so
Yeah, and to add, Lumigo also has a great offering with AppSync. So again, especially if you have your, I mean, I've been using Lumigo for a few projects for some time now, and I would highly recommend Lumigo as well. You can try it out. It gives a lot of alerts and everything out of the box, and gives some good views as well.
got it. Yep. So the GraphQL is the AppSync API is being deployed to cloud. So the next step being we'll have to create users on Cognito user group so that we can use that user as an authentication way. Use that user's credential for authentication for our APIs. The simplest way of navigating to the console and creating these users is amplify console auth and so yes. Yep. So once we do amplify console auth, it navigates to the user group that we have created. We'll be creating a user here. So the simplest way to create a user is from the console. So we say test as the username. We'll provide a temporary password. We'll also mark this user as email verified. The next step is since our APIs are authenticated with uh, uh, Cognito user groups, we'll have to create a user group with the name managers. Um, we could optionally create a IAM role so that each group has a different IAM policy, which has different access to different AWS resources for fine grain access. So we have created the user, and the next step is to add the user to the group. Once we have added the user to the group, we'll go back into our terminal and navigate onto the AppSync console. So we say Amplify console API navigates us to the API that's been created on the AWS console. So GraphQL. So this was the API that we had. This is the app GraphQL API that we had created, and you can see from the console, it's navigating us to the queries tab itself. We can even view the complete schema. So what I was sharing from my local code base, the schema has been uploaded, and also it has added different resolvers for it. So yeah. So you can see that the mutation is using different pipeline resolvers. Uh, there's there's a private node of the type object which is using owner with a pipeline resolver. It has created a DynamoDB table. It has created two DynamoDB tables, and also has created the IAM policy for these tables. All these things is done under the hood by Amplify CLI itself. That's provisioning DynamoDB tables based on the model that we create. And whenever it's adding it as a data source, it's providing AppSync the IAM permissions to access these data sources. Since most of the mutations are using pipeline-based resolvers, it's creating different functions. Like I was showing you, one of the example being a auth-based function. So you can see that the complete VTL-based resolver is added here with the request and response mapping template. Uh, so this is one of the function which is using managers as a computer group based access control. Let us head on to queries, and we'll log in with the user that we created. Since we created the user from the console, we would have to recreate our password. So that is in a first change password state. So we had to create a new password. So you can see that from the console, one of the easiest ways of testing AppSync based queries is from the console itself, where it provides an IDE for us to choose between different queries, different mutations, and different subscriptions. We'll go with the mutation first, and let us say uh, create private node, and we can specify what the content is. So demo serverless Saturdays. And whenever we are creating, we can even request for certain things as a response. Since it's a type private, since it's of a type node, it has certain values like content when it is created, the ID, the owner, and also when it is updated. So you can see when we run the specific mutation, in the background, it's creating this private node on DynamoDB. And as a response, it's returning all the parameters that got updated on DynamoDB. So we can create certain other things also. So say Serverless Saturdays, AppSync, and we can do a query to retrieve the values. So we can say list private nodes, limit. We can specify the limit for pagination purpose. We can even say 10 and items. So you can see here that the structure of uh, the structure of the response is it has items which has a list of note object itself. So each of them we can either request for the content alone, the content and ID. When we are requesting with these two parameters, the main feature about uh, GraphQL is you get what you request for. So here in this case, we are requesting for content and ID alone. So when we run the query, we'll be getting only these two parameters as a response. So based on this, we can even create uh, uh, less less traffic or less payload based responses, uh, so that you don't get something that you don't require and creating I mean, you're sending something that's not really wanted by users. So it's a waste of all the space, or the space, the waste of the size of data that's being returned as response. That is being optimized with GraphQL. That also adds on to one of the point of why choosing AppSync over REST APIs. So whenever we are doing different mutations, we can even, let me just duplicate this. So whenever we are working with different mutations, we can even have real-time updates with subscription. So what we can do is, whenever there's a newly created private note, we can say that if the owner is a specific user, or whenever we create a specific task, we can say that all these parameters that are there should be returned to the front-end client, so that it enables a easier way of creating real-time updates. You don't have to write your own logic here, where the server is taking the data, posting it out to everybody who's subscribed. All this is being handled with AppSync itself, where any change in the data that's there uh, with a specific mutation, we can even specify different filters with subscription, and and whichever data has that specific value, only those is being sent to the client that's been subscribed with the specific filter also. So in this case, let us subscribe to on create task, and in the new tab, we'll be creating a new task. So you can say subscription demo serverless Saturdays. Whenever we are creating, we can even choose what are the parameters that we need. And once we run this mutation, we get the response. And in the subscription as well, the client which is subscribed to this specific mutation also gets a response, making the real-time based applications really fast for the updates to be received. So whenever we're trying to create, so let us create one more user with just two. So we can log into this user. So one thing about this user is not part of any group. So when we are trying to create, so when we are trying to call certain mutation, since this user is not part of the group, one of the pipeline resolvers itself validates this condition and throws an authentication error. So let us say we are trying to create the same mutation. When we are creating, there's a message that says you're not authorized to create task on type task because there's pipeline resolver that's checking for the authentication of the user and ensuring that users with the who are part of the group as managers only have access to this. The other way of doing this specific validation is with the auth based directive that's available on AppSync, where in one of my slides, in one of my slides, I had a snippet of code which mentioned whenever the user is part of a group owner or part of a specific group, they have access to the mutation. Uh, here there's a pipeline resolver that was created from the template, which is doing the same action. So that's about the demo on AppSync. So one of the authentication based access control is what I was mentioning here. We can use AWS auth as the directive, and we can specify if the user is part of certain groups where AppSync itself, without the pipeline resolver, where you would have to write the code, AppSync itself validates that the user is part of the group or not. So that's about the demo. Hope you had an insightful session about AppSync. Thank you. You can use my different social media handles to connect with me. If you have any questions about AppSync, you can DM me on Twitter. And also, I have a AppSync blog post that's available on my Dev2 handle. So thank you, everybody.
Thank you so much, Jones. That was an amazing session and a great demo as well. Thank you so much for that. And I think there are a couple of questions. Yeah.
Okay. So to answer Naveen's question about pricing, if the traditional REST API based queries and mutations is what you're looking for in AppSync, it's certainly cheaper when compared with API Gateway. But if you're going with something with real-time updates with subscription, that's where you would have to think about cost optimization, because under the hood, it's still using uh, the mutations and the cost for each mutation that's been sent to each subscribed user. So that's one of the things that you would have to consider, that you would have to be worried about. Otherwise, I would say the REST APIs via API Gateway is certainly cheaper. Certainly, sorry. Let me rephrase it. So, yeah, AppSync based queries and mutations is certainly cheaper with REST APIs that's been deployed over API Gateway. So, Shrishit, anything that you could add on to in terms
Yes,
of
yes,
pricing?
I would. Yeah, I would totally agree to that. And sometimes I feel API gateway is probably one of the costlier of services comparatively, and with a lot of stuff that you can do with resolvers itself on AppSync, I think we can reduce all the lambda cost as well. So yeah, I think AppSync probably will be cheaper. Again, depends on your use case, as Jones mentioned. Okay. Next question.
Okay. So, to answer Udit's point, subscriptions are something that's useful for real-time updates. Like I was showing you in my demo, whenever there's a change in data with a mutation that's being called from any user itself. So if you subscribe to a specific thing which is tagged to, so let me show the schema itself. So you can see that whenever we are creating a subscription, we can subscribe to certain mutations. So whenever there's a change in data with respect to a create task mutation that's being called, if you subscribe to it, you'll get a real-time update because uh, here we are using the directive AWS subscribe, which is listening to any of the changes that's been done with this API endpoint and any client that's been connected. So you could have thousands of clients that is connected to with this GraphQL endpoint, and any client calls this mutation, you know that there's a change in data, and this change in data is what it uses as subscription to notify to anybody who is subscribed to this specific subscription.
Yeah, I think
Um,
we have a question from Karthik, right?
Okay, so I think Karthik is asking for the AppSync authentication with IAM role. That is, if I need access to AppSync from Lambda, I don't have to create access to it. For user, instead, any better way to avoid that? Okay, so is Sushil, let me just understand the question. The first one was about IAM auth, which is the auth type for GraphQL endpoint, correct? And now I'm trying to understand that he's asking a question where we can use authentication type which does not require access token for a user, which is
Yes,
primarily asking if it's IAM role itself, right?
right, right.
Okay. So whenever we want to create a different auth type, so let me just go here. AppSync provides different authentication methods where IAM role is one of the auth type. So here, what we can do is we can have a IAM role that's been created for identities on identity pool. So whenever there's a user that's created or identity that's been created on Cognito identity pool, we can have authentication roles and unauthorized roles. With these roles, we can provide access for that identity to invoke a AppSync to invoke AppSync based APIs. With this IAM policy, if the client is using Cognito identity pool as one of their ways to identify the user or the device that's connected, these identities have access to the IAM role based on the policy that we define for authorized role or unauthorized role. From this IAM policy, we can invoke AppSync mutations and queries. So what we can do is, let me see if there's identity pool. Oops. So the console has timed me out of. So, so just for example, so, when we were creating an user pool, identity pool is also created here, and during this there is a IAM policy that we can create, IAM role that we can attach for authorized and unauthorized users. With this IAM role, we can add an IAM policy which has access for invoking AppSync. So from this IAM role, we can invoke the APIs, and we can change the authentication uh, method for our AppSync API to IAM role. So I hope it answered Karthik's question.
Yes. Yeah, I think that was again. Thank you so much, Jones, for answering all the questions so patiently. And I've already posted your Twitter and LinkedIn links on the chat section. So anybody from the audience, if you have any more questions, you can always reach out to Jones. And yes, here are the his Twitter ID and everything. So please do reach out to him, or you can reach out to us, and we can get your questions answered. Thank you so much, Jones, once again for joining us here on a Saturday and helping our audience get started with AppSync. And thank you for the great demo.
So thank you, everybody. Go serverless.
Thank you. Thank you.
Thank you, Jones.
Thank you, Karthik.
So before we go further with our second session, we have just 1 hour to go for our quiz, a serverless quiz, and the winner of the quiz wins $50 AWS credit, and the link you can find in the description, as well as it is available in the comment section. I'll paste it again, and all the questions are based on the sessions that are currently happening. So do take part and register yourselves on the Quizzup platform. And without any further ado, I would like to bring our second speaker of today's Serverless Saturday, Vineet.
Hello, everyone. How's it going?
Hey, Vineet.
Hey. Really nice talk about AppSync by Jones here. I really love AppSync, as you all know, and it was great to see a different vision of it. Yeah.
That's awesome. So first of all, welcome to Serverless Saturdays, and we are so happy to have you here today talking about step functions. Again, another very interesting and very useful service for folks using with serverless. First of all, how do we pronounce your name? I think both Karthik and I are just getting
Yes.
it wrong.
Yeah, I can say Benoit.
Benoit, is that correct?
Correct.
Benoit.
Oh, okay, that's great. That's great. So yeah, he's joining all the way from Spain, and he's been. I think it's probably what 8:30 in the morning over there.
It is, yeah.
Thank you so much again for joining us so early for you, and helping our audience get started with serverless. So, without any further delay, over to you. You can just start with your basic introduction and we can get started with the session.
Can I bring my slides in? Oh, yeah, thank you. All right, so today I'd like to talk a bit about step functions, which is a really great service that I think most of us really enjoy in AWS. And for those who don't know it already, well, we'll give a quick introduction, and then we'll see a bit of some advanced usage we can do with it. So first of all, a few words about me. I am Benoit, a serverless developer at Serverless Guru, and I've been using serverless since around 2018 or so. I started actually with AppSync, which is a really great service, as we also. And since last year, I've been a AWS community builder, and you can also find me if you want on Twitter and GitHub, most importantly. And there's also a blog that I try to maintain with a lot of things about AppSync again and serverless in general. Right, so let's start with step function. So what is step function? Well, as per AWS documentation, step function is a low-code visual workflow service that developers use to build distributed applications, automate IT, and business processes. If that sounds a bit gibberish to you, don't worry, I have a better definition. When I was a kid, there was a great game I loved to play called The Incredible Machine. And that game was giving you a challenge. So in this case, on the right on the screen, you can see you were received a ball, and the challenge was put the basketball in the basket. And in order to do that, you would be given some different parts here. You can see some springs, like a flipper here, and stuff like that. So the goal was to put those parts on the canvas, and then when you hit play, the ball will just start rolling and jump everywhere and go from part to part until it eventually gets, hopefully, in the basket. So that's kind of how I see step functions today. You receive an input, your step functions receives an input, and the goal is to achieve a output, a different state. here is put the basket in the basketball, while in step function it would be get go to a different goal, like take a payment function, for example. And to do that, you use different steps, and the steps are like the parts in the game. So there are different mechanisms that you can put on in your step function, and then the input will go from one to the other and transition until you achieve your goal. Another way to see it is like it's an orchestration service, so it can coordinate different services from AWS and different processes to achieve your goal. Okay, so now that we have a quick introduction of what it is, let's see what the benefits are. The first one, of course, is that it's fully managed and serverless. So you don't have to maintain any server, you don't have to do anything. AWS does that for you. And as I explained earlier, it also breaks some complex processes into different smaller steps and smaller pieces that are easier to maintain in the end. And of course, it integrates with nearly all AWS services. So as you will see later, step functions on its own, it doesn't really do any work. It doesn't do really anything. It just coordinates different services and different pieces of work to achieve your goal. And also one good benefit, at least with standard functions, that we will explain what it is later, but is that it's kind of really easily to debug, because you have an inspector, a graph inspector that allows you to see exactly how an execution transitions from one step to another, what happened, where the errors happened, etc. So here is an example of a very basic and very simple step function workflow. So imagine you have an application that receives orders, and you need to process them and eventually fulfill them and to send to the client. So what you would do, instead of putting everything in a Lambda function or in an API, what you would do is break it down into smaller pieces and put it into a step function. So the first one could be, well, check the inventory. So maybe we need to check that everything the user ordered is available in our inventory. Otherwise, we can ship it or we can create those. So if they are, here we have a like an if or a choice that decides what to do depending on the response. So if there is availability for the product, well, we will take the payment. And once the payment is taken, we know that we can fulfill the orders, and we are going to do that, plus also maybe generate an invoice and send it to the client. If there's no availability, well, maybe what we want to do is cancel the order and then notify the user and let him know that, well, it couldn't be possible because we are missing some pieces in the inventory. Right. How do you build workflows? Well, the first easy one for beginners, at least, and even for more advanced users, is the Workflow Studio. It's a very simple, it's quite new, but it's super easy to use. You can drag and drop different pieces of infrastructure, Lambda functions, whatever you're using. You put it together, and then you can export it to a JSON or a YAML. And we will see why this is useful right after that. You can also import from JSON YAML. So if you have already a structure in your infrastructure as code as a YAML or as a JSON, you can import it back to just visualize it and then edit it and then maybe export it again. Another great feature about the Workflow Studio is the availability to export to to SVG and to PNG. And I find this very useful for putting into the documentation, for example. Now, the second way to build state machines, step functions, is using the Amazon State Language, also known as ASL. So it's the code version, basically, of the step function. is written in JSON or in YAML. So that's why from the workflow, it's very useful to be able to export to YAML, because then you can re-extract it as an ESL. And why is JSON and YAML useful? Well, because you will be able to put it in your infrastructure as code and maintain it and version it into GitHub, for example. Right, so now there are two different kinds or types of step functions. The first one is the standard functions that are the ones that have existed since the very beginning. And there's a fairly new one. I think it was introduced in 2019 in the AWS it is Summit. I don't remember the name right now. Yeah, there are a couple of differences about these two. And Express, as its name is telling, is that they are meant to run really, really fast. And the trade-off to that is that you will not be able, for example, to debug it into the visual, the graph, Visual Studio. But the advantage of that is that you can actually run much more execution at the same time. You have more throughput, and it's much quicker. More differences. In standard functions, you can use a pattern that is called the callback pattern, that I will also talk about a bit later, which is not possible in Express because they are meant to be so fast. Well, you can't really wait and do async job in these kind of functions. Okay, so now, what is a step function composed of? The first piece of step function is a task, and a task, as its name also tells, allows you to execute some work in a state machine. There are maybe two or three use cases for that. The most important ones are EC2, so you can send a payload to an EC2 that will do some work. But since we are talking serverless today, maybe the most important one would be AWS Lambda. But you can also use other services, but we are not going to go into the details here. Another piece of another part you can use in step function is the pass step. So what it does is it basically just passes the input back to the output. So in step function, every step receives an input and outputs an output. And a pass, just passes through the data. And it's usually useful if you want to debug or test, or maybe do some simple proof of concept of a step function, and you don't really want to add some work yet. You just want to simulate what the step function would do at that point. And in the end, and later on, you would just implement the real logic. Then there's the wait state or step. Basically, what it does is waiting for a specific amount of time. It could be in seconds, so wait for 20 seconds, 30 seconds, whatever. Or you can also set a timestamp in the future. Maybe you want to execute tomorrow, so you receive that payload with the date of tomorrow, and then you pass it into the wait step. And when the timestamp is reached, well, then step function will continue. Again, it's a step that doesn't really do anything apart from waiting. It doesn't do any work. It doesn't transform the data. Usually, you would just pass the input back to the output. Then we've got choice, which I've showed a bit earlier. So in the case of the order, we would check if there was an inventory or not, and do something depending on that condition. Well, that's exactly what it is. Choice is like an if statement in your favorite programming language. you receive you configure a bunch of different conditions, and they are evaluated in order. And the first one that evaluates to true defines and tells step function what to do next, so into which state or which step it should transition. So on the right, we've got an example. We've got to choose. Imagine you receive a value that is a number. If it's greater than 50, we'll go left. If it's less or equal to 50, we'll go right. One thing about choices is that you can have as many conditions as you want, but there's also like a default choice, which is corresponding to the else, basically the else statement of your favorite language, which is going to define where a step function should transition if none of the conditions is fulfilled. And this is a good practice to actually define, because otherwise, if none of the conditions are met, step function will just fail. So instead of that, you just want to do something special. Maybe you just want to raise an alarm or something, or do something custom. The next one is parallel, and again, the name is pretty explicit. It allows you to run different branches of workflow in parallel. Every single branch of the step will receive the exact same input, and it will just be executed at the same time. When the last branch finishes, only will the whole parallel state finish. So the step function cannot continue until every single branch has finished processing. And the output of the parallel state will be an array receiving the result of every single branch in the same order that you define them in your ASL definition. And if any of the branches fails, then the whole step will fail. There's no partial success or partial failure unless you handle it manually with error handling, which we'll talk about later again. And then, every branch is executed completely independently from the others. So they don't interact with each other. They don't receive or pass any information between each other. They're really independent. Okay, next is a map. What is map? Basically, the map step is, or the map flow is a way to do loops. So it kind of relates to for loop in traditional languages, where it receives an array or a collection of items, and it will execute the exact same branch with the same input for every single item. It supports concurrency, so that's a bit different from a traditional for loop, where it would usually be executed one at a time. But maps actually allow you to execute them in parallel, depending on how many items you receive. So you can say, okay, I want to execute 10 items at a time. And if you receive 100 items, it would execute 10 batches of 10. Again, just like parallel states, it will finish only when the last item has been executed. And unless you handle it manually, if any branch or if any iteration fails, the whole step will fail, and then an error would be thrown, and unless you catch it and do something with it, then step function would fail as well. And two very basic and simple kind of states are the fail and the succeed one. As their name tell, the succeed will just mark usually the end of a branch or the end of the state machine as a whole. In a succeed state, which means everything went in a happy path. And then there's the fail one, which you could use if you want to force step function to stop and show in a fail state. So in that case, it would show in red. You would see it in the console, and you would be able to maybe go and debug to see what happened. All right, so in step function, the way it works is that it receives an input, passes it into the first step. The first step gives you an output, which is passed to the next step, and etc. But sometimes you want to manipulate and to transform or customize how the data and how the information is passed from one step to another. And there are actually 5 different techniques and 5 different ways and attributes in the ESL language you can use to do that. And the first one is input path. So imagine you receive a big payload from your caller, but the first step or one of your steps doesn't really need everything. It just needs a subset of it. So what you can do is use the input path in that specific step to tell it which part of the big input from step function you need to inject in that step in order to work. So that avoids you sending a big payload, maybe in a Lambda function, where you just need one subset. Here's an example. So on the left, you can see that maybe the input of the step function receives some details and some values, but your first step, it only really needs the details part. So what you do is that in your ESL, you will define the input path and specify the path in the input that should be passed to that task. Notice here that I used a notation that uses $sign dot details. Well, basically what it uses, it's the JSON notation, path notation. So dot details means take the input and take the details attribute from it, and that is what you need to pass to the step. And on the right, you would see what the task or the step would actually receive, which is in this case just foo with a 1, 2, 3. So in this case, values is completely ignored. Then sometimes you also want to maybe change the shape or the structure of the data that is passed to a step. So that's what parameters allows you to do. So what it does, it generates a key value object that is used and passed into the step. And you can use whatever you like. You can define all the attributes, the keys that you want, and pass it either values from the input, but you can also pass, if you want, some static values. So that's useful if you want to enrich the payload with some other data. So in this case, we have parameter here on the state, which defines a message, and the message comes from value.bar, which in this case is hello, and we have a static value of world. And on the right, you can see the result, and that is actually what is going to be injected into the state, which is hello, message hello, static world. Then when your state or your step is executed, it will return some value, some output, and you can also, if you want, transform that and use different customization to continue and in the state and in the step function. So imagine that here we have a Lambda function that returns some payload on the left. Again, it's the same one, details and values, and you want to transform that to continue into the state machine. So what you would do here is you can use the result selector to transform that. In this case, what I want is to change that, and I want the output to be a message with hello, and numbers with 1 to 3. So what I can do is use the result selector, and I use message, and I pass it value dot bar. So it will take hello from the output of the state, and numbers would also take details dot foo, which in this case is 1 to 3. So the result and the new output of the state is actually, again, it's message hello and numbers 1 to 3. One thing I think I forgot to mention in one of the previous slides is that if you look at my ESL code here in the middle, you will notice that some attributes have a $$ sign at the end. So you will see message $$ or numbers $$. In ESL, the way you specify that the value you are passing is in actual value that comes from the state, from the input or the output, is using a $$ sign. Otherwise, if I would just put message semicolon, message colon $values of bar, that would mean that you would pass the actual $values bar as a string, and it would not take the input or the value from the input. All right, so the next one for manipulating the state is the result path. And this one is really useful, especially if you use it and combine it with the previous ones, because usually, and by default, the output of a step is the one that is going to be passed as the input of the next step. So if you use, for instance, the input path for a state, then it transforms it, then it outputs some new value. That new value would be what is passed to the next step. But sometimes you want to carry over whatever came in input of the state machine, carry over what is the whole message, even though you don't need it inside one specific step. You want to keep everything together. So the result path is actually allows you to tell step function where in the original input of the step you want to put the output. So in that case, you would keep everything together. You would just enrich and keep enriching the input with whatever is transformed or produced by your different steps. So here's an example. Imagine you have a step with an input, which is, again, it's the same one, details and values. In this case, I use a pass, so I use some parameters, which is telling what is the input of that step. So in this case, I just mock it and create message hello. And I specify also the result path and tell it, okay, well, whatever comes out of this step, put it in the input in the result attribute. And on the right, that's exactly what you see is happening. So we kept and we carried over the details and the values attributes, but we enriched it with the result. And that is actually what is going to be passed to the next step. The next one, also a useful one, is output path. That's kind of the opposite of input path. And it tells the step function what to extract from the output and pass over to the next one. So in some cases, you have a step or a task that would produce a lot of data and it will return it, but you don't really need everything in the rest of your step function. So you can tell step function what is the part that you are interested in and extract it and pass it to the next step. So imagine here, again, we have the same example, a task that outputs details and values, but I'm telling it to only extract details. And what it's going to do is extract that object contained into the details attribute, and that is what is going to be output to the next step. Okay, finally, you can use all of these together and I think it makes sense to maybe show a quick example because the order in which they happen is important here. So imagine that you have a task, in this case it's a Lambda function, and we have defined here every single of these attributes that we've just discovered. So the first one that will happen is input path always. So imagine on the right, top left, you will see the inputs of your state machine, which takes data, then some input, and some metadata. But I'm telling, okay, well, for this step, I just want to inject data.input, which in this case is just foobar. But then next, what I do also is I say, okay, well, I want to transform that, and I want to pass some custom parameters into the step. And what I do is I will define a custom payload again with input message. Here again using the dollar sign to tell it it's an input path, and I just pass it $.foo. So here the thing that you need to notice and keep in mind is that input path is always executed first. As you can see, in the parameters, I only need to call and specify $.foo because input path already executed. So what I'm left with is just an object with foo and bar. So at this point, $.foo is just the value bar. And then I also do an extra message where I just pass some hard-coded value. It's a string, hello. And then on the top, in the bottom left, you will see the actual result of these two operations. And this is what, in this case, the Lambda function will receive in the event parameter when it's executed. Then, well, the Lambda function is executed, it doesn't work, and imagine that it returns this message on the top right. It's just a JSON object with a message and some string. And that's what will come out of the step in the state machine. So step function at this point will receive message with hello from Lambda. But then we also have here some manipulation of the state where we say that the result selector will reformat everything, and it will just create an object with an attribute which is lambda result, again passing the dollar sign here because we are referring to a path in the output this time, and it takes the message. So in this case, it's hello from Lambda. So here on the bottom middle, you will see that this is what happened. We have a Lambda message with hello from Lambda. But you also see that it's being placed in the original input in the result, in the data.result path. And that is because we described in the ESL that the result path should be data.result. So what it does, it takes back the input and put whatever was created by the result selector into there. And finally, what comes into place is the output path, which in this case will describe what we need to extract from the result to be passed to the next step. And in this case, we say it's $.data. So in this case, metadata would just be dropped, and we extract everything that is inside data. And this is what is the final output of the step. So in short, in what order do these attributes take place? So first in the input is input path, then parameters. And when the output is returned, first will result selector be executed, then result path, and finally output path. So the order is really important here because it will affect how you will manipulate the data and how you need to you need to understand how it works and how it will be executed in order to do exactly what you want. Okay, there's one more important thing about step function, and it's the context object. So in step function, you always have an input, which is what is passed to your step function by your caller, but step function also gives you a context object, which describes different things. The first one is the current execution. So you will receive the ID of the execution. You will have a copy of the input. You will receive the name of the execution, because each step function execution has a name, which usually has to be unique, otherwise it will fail. The ERN that is used when it started, and also it will receive information about the current state, the current step, so the name in which it is currently and when it entered there. And finally, also the number of retries it has been doing for this specific step. And that can be useful later, which we will see in a minute. Okay, so one more cool thing about about step function is intrinsic function. Intrinsic functions are a great way to also manipulate the input that comes from your caller. And they are basic functions that you can use in ASL in order to transform usually some string or some data. And it's part of the Amazon state language. There's actually only 4 of them, but they are usually very useful. The first one is the state dot format, and what it does, it takes an input string and some placeholders, and what it does is replace whatever values you append to the call, and it replaces every placeholder in order with the values you pass. So the placeholder are described or specified with 2 curly brackets. So in this case, in the example, you will see, hello, my name is double curly brackets, then you pass $name, and imagining that the input receives an object with name and Ben, well, what message will contain is message, hello, my name is Ben. Another one is string to JSON, and basically, as its name is telling you, it will transform a stringify object as a string into a real object. So in this case, we could see that we receive a message hello stringified, and a string to JSON will just parse it and output a proper object. If you use Node.js, that's the equivalent of JSON.parse, basically. And then we have the opposite one, which is stringify, or in this case, JSON to string. It receives an object, and it will generate a stringified version of it. So it's the version of JSON.stringify in Node, if you will. And the last one, it's state.array, which takes as many attributes, as many parameters as you want. And what it will do is generate an array with every single of the input values in the same order, and output it to the next one, and put it in this case into input into the input parameter. All right, so we talked about briefly about errors earlier. So there are actually 2 cool ways of handling errors in step functions, and the first one is retry. And as its name indicates, retry will just allow you to retry a step if for some reason it fails. The retry attribute takes an array of retry policy rule definitions. And on the right, you can see an example of this. So the first attribute is actually error equals, which basically is a comparison rule. So it will look at the name of the error, and if it matches any of these in the array, that's the rule that is going to apply. So you have three different configurations you can bring here. And the first one is the interval in seconds, which describes how many seconds step function should wait before actually retrying this step. The second one is the backoff rate, which indicates a factor with which step function should multiply the interval in seconds between each retry. So it gives some backoff time for maybe the underlying service to recover or something like that. So to take an example, the first time here in the first definition that Lambda will retry, it will wait 1 second. Then the second time it will wait 2 seconds, and then 4 seconds, etc. Until max attempts is reached. In this case, it's 3. So after 3 retries, step function will stop, and it will either send an error and fail, or it will transition to the catch rule, which we'll discover just in the next slide. Finally, one last thing is that you have some special error names that you can use in order to do it like a catch-all if you want. In this case, states.all means match any error. So in the example, if we receive some error, what it will do, it will try up to 3 times, wait 1 second, 2 seconds, 4 seconds, then it will fail. But if the error would be something else that is not some error or other error, what it would do is transition to the states.all definition, and in that case, it would wait 5 seconds, then 10 seconds, because the backoff rate is 2, and in the end, it would just fail. All right, so the catch. What's the catch here? Well, when you have a state or a step that fails, you sometimes want to do some custom handling. Maybe you want to handle the error gracefully, or you want to send a notification to someone, maybe. So the way you want to do that is using the catch attribute in the ASL definition. And again, here it takes an array of catching rows that will define how step functions should react in case of one error or another happens. So in this case, we have some error. Well, if the Lambda function in this case would throw some error that is named some error, what it would do is that step function would try to transition into the handle some error step. And that's where you would do some custom logic, maybe handle the error, do something else, send a notification, whatever. But also what you can do is, as in the retry policies, you can define a catch-all if you want. In this case, that's what states.all means. And in that case, it would transition into a different step that would be handle error. So that's a way to handle different errors differently. So maybe some errors you will want to retry, but some other errors that you know are not transient errors, well, you may want to fail immediately or do something different. Finally, both in retry and in catch policies, if none of the definitions, none of the rules match, then step function would just stop and fail completely. Okay, so one great thing, I mentioned it earlier about step function, is the integration with all the other AWS services. The most famous ones being, for example, Lambda, SQS, SNS. So in step function, we have 2 ways to integrate with different services. There's the optimized integration, which integrates 15 plus services I counted. So these are the classics: DynamoDB, EventBridge, Lambda, SQS, etc. But if you want, you can also use the new SDK integration, which allows you to call 200 plus services. It can be anything, and we'll see that a bit later. So in the optimized integration, as I mentioned, the famous ones, the common ones, SNS, SQS, DynamoDB, and step function itself, by the way. You can call step functions within step functions if you want. So here's a quick example. We have a step that calls SQS. So what it would do is place, in this case, a message into SQS, and then it would transition into the next state. And here's an SDK integration example. Again, it integrates with nearly any services of AWS, and it allows you basically to achieve what we call zero-code workflows, but by avoiding a Lambda function to call maybe a different API or the SDK from code, while you can do it from step function itself directly. In this example, I am calling the SSM to get a parameter from the store and pass it over to the next step. Right, one last really fun thing about step function is the callback pattern. Basically what it is that it allows you to wait and have step function wait until some different asynchronous job, or maybe a human wants to validate some tasks. So it allows you in a way to execute asynchronous tasks. So what you would do is use the wait for token in the resource name, and I will show an example of that in a minute. That will tell, okay, well, step function, at this point, you have to wait and until I tell you that I'm finished with some other job somewhere else. And when that other job is done, it will send a task success or a task failure, depending on how the task was executed. And as I mentioned, there are two common use cases for that, is maybe human approval and maybe waiting for another job to finish. And yeah, so I think it's time for the demo now. And that's exactly what I'm going to show you if we still have some time. So I will try to share my screen. So I hope you see that. All right, so can you all see my screen? I'm going to put you over here. Yep, Inception. Okay, so let's see a bit. So here, imagine that we have an application or a store that receives some orders, and what we want to do is receive the order and then process the payment. But because we have a very successful store, we don't want to overwhelm our payment provider and avoid to send too many requests at the same time. So what we want to do, the goal here is to put the payment step and extract it into a way where we can control a bit better the flow and how many requests are executed at the same time. So here I've got my ESL definition for this step function. And what it does, it receives a payload, say it's an order, and what it will do first is that it wants to send it to SQS. Why SQS? Well, in this case, SQS is a queue, which is a FIFO queue. So what the goal is here is when we receive many requests and many orders, we got all our step functions starting at the same time, but we want to buffer, in a way, the call that is being made to the payment provider. So here we are going to use the callback pattern to do that. So as I mentioned earlier, in the resource, we are calling here SQS, and we send a message, and we wait for a token. And we will see how that works later. So here we've got the queue URL, which is where the message should be sent. Because it's a FIFO queue, we also have the message rope ID and the payload. So in this case, we pass the order that comes from step function and the token coming from the context from step function. So you can see here I use two $signs, which is accessing the context. And the context also, in this case, contains the token. And the token is generated by the wait for token notation here. So that token will be used later. We will see how to actually tell step function that the job finished. After that, we will fulfill the order and finally succeed. Okay, so let me show you maybe now. Next is what the SQS worker actually does. So here is the lambda function that will be executed by SQS in order to process the payment. So what I've done here is that I mocked it, and I'm calling a pipe dream endpoint, which we will see in a minute. And when the payment processor returns a success, then what we do is that we send to step function a task success, and we pass the message as success as well. So that lets step function know that the payment was successful and we want to continue. But if the payment failed for some reason, then what we want to do is send a task failure command, which will let step function, in this case, know that the payment failed. And we pass a message. We could pass the reason of the failure, but in this case, to simplify, I just say payment failed. Okay. So the next bit I want to show you is maybe I would show you the step function itself in a more graphical way. Let's go in here. Okay, so you can see we receive here. We receive an order, so it is being sent to step function, and at this point it will wait. If it receives a success, we will transition to fulfill order and then finish. But if it fails, we will transition into the fail state, and the order will not be fulfilled. Okay, so now here I'm going to show you quickly what is a simulation of the payment processors. That's the payment gateway. It could be Stripe or PayPal, whatever. So what I'm going to do here is simulate that some payments will have success and some of them will fail. So here in this case, 90% will succeed, and we will have 10% of failure. And then we will do some wait here to simulate the actual payment and also give us some time for the demo to see how it works. Okay, so finally, one last bit is that I have a quick script that will generate 50 random orders, and it will place them and call step functions with the payload. So let's actually execute that and see what happens. Okay, here we're creating 50 orders. So now if I go to my step function, and if I refresh, we should see here, we've got a bunch of orders that started, or step function execution that started, and some of them have succeeded already, but some of them are still running. And why they are still running? Because if I go to SQS, we still see here that I have some payments or some messages that are still in the queue to be processed. So what happens here, we've got huge bunch of step functions that started at the same time, but we are buffering the call to the actual payment gateway, so we don't overwhelm that resource. You can see if I refresh, here it's almost finished. And if I go to my simulation of my payment gateway, we can see that we keep receiving one at a time all the payment request. Okay, so I think it's done now. So here, yep, you can see it's done. And if I go back to my step functions, execution, you can see that some of them succeeded and some of them failed. So maybe let's go and start with the success one. And as you can see, first the message went into SQS, it was processed, we waited for the token, and when the token, when the Lambda function sent a success call, we went and we fulfilled the order. But in the case that we sent a failure because the payment failed, in this case, well, step function transitioned instead into the fail statement. So here, maybe we can raise an alarm, send a notification to someone, maybe someone has to review what happened, depending on the use case. All right, so that's it. If we do have some time, I do have a second demo that we can do. And imagine that for some reason, your payment provider goes offline for some time. So here, this is what I'm going to simulate. I'm going to edit this code, and I'm going to simulate a 500 error returned by our payment gateway. So let me clear that out so we can have a better visibility. So what I'm going to do now is that I'm going to create some new orders. Maybe I'm going to create just 10 for this demo. And yeah, so now I should have some new executions here. They all started, but as you can see, they are all still running. If I go to SQS, I will see I have 9 messages in the queue and 1 is still in flight. But if I refresh, you will see that they are not going through. And why is that? Well, because if we go into CloudWatch and look into this, we will see that, well, our payment gateway is offline, it's returning a 500 error, so Lambda is failing, and the message stays into the queue. So what SQS is going to do here is it's going to retry and retry until the payment succeeds, or maybe the payload, the message goes into the dead letter queue. If I go into here, we will see that SQS keeps retrying, but the payment gateway keeps returning 500. So the payment stays there. And while the payment stays there, you can see that step function is still waiting. Now, imagine after half an hour, 1 hour, whatever, your payment processor comes back online. So I will simulate this here by just changing the return to a 200 success response. I will deploy that. And if we wait now a few seconds, we should see that SQS, because it's retrying, will retry. And because we have a success, then we should see all the payments start to succeed. So while we wait that, I will maybe try to explain why is this useful. Well, even though step functions allows you to do some retries, well, at the end of the day, you will usually maybe retry 2, 3, 4 times, depending on your use case. But at some point, step function will probably usually give up, and the step function will fail. And then when your payment processor comes back online, well, suddenly you have to restart all your step functions, or you have to ask your customers to maybe replace the order, which is really not convenient. So what we do here is that instead we allow SQS to do the retry, to do the buffering, but also if at some point the payment gateway comes online, it will retry. But if at some point also the message goes to or the retries are being exhausted, what SQS will do, usually it will send it to a data queue, and that data queue, well, is keeping all the messages. At this point, step function keeps waiting. There's no problem with that as long as the timeout doesn't expires. Step function will keep waiting, and when your payment processor comes back online, you can redrive in any case those messages that went into the letter queue, and step function will just keep waiting and continue as soon as you send a payment, a success token. So as you can see now, after some retries, step function, SQS in this case, actually was able to retry and succeed, and our step function should all have succeeded. Well, or in this case, it has failed because the payment failed. But what I wanted to show you is that this pattern is not only useful to actually buffer the execution of maybe one small step, but also for resiliency. So in this case, we can easily replay all the messages if there was any issue. And yeah, I think that's it. We are about out of time here. So, oh yeah, there's actually one last thing I wanted to show. If we can, I would like to, how do I do that? Stop screen. Can you share back my slides? Okay, thank you. So the last thing is, that was the demo. A couple of weeks ago, I discovered a really useful tool called StepView. It was built by Vincent Claas from the community builder team as well. And it basically allows you to show you a summary of all your step functions and how many of them executed, how many of them are in process, how many failed, what is the percentage of the failure and success. And I thought, it was a really cool tool that I wanted to share with you as well today. And with that, we are done. So thank you very much. And if there are any questions or comments, please just let me know.
That was a great session. And first of all, thank you for your dhanyavad. It's so nice of you to put it in Hindi over there.
Yeah.
So yeah, thank you so much. And it was an amazing session, especially the demo. I think the audience would have loved it to see step functions getting fired and then SQS and it getting successful and fail. It was an amazing session.
Yeah, thank you.
I think we do have a few questions.
Yep. Are there any limitations of using step functions? Yes, there are some quotas that you need to keep in mind, especially with standard step functions. The first one is that you are allowed to execute only, I think it's 25,000. Well, you're only allowed to keep 25,000 in the history of one single execution. So the way step function works is that every transition between one step to another is one or several events that happens in kind of a list that is kept in the history. And there is actually a hard limit of 25,000 execution, 25,000 events. As far as I know, it's rarely an issue unless you have very long-running step functions executions. It's usually not an issue. I think if I go back to my slides at the very beginning, there's also a few more limits. So here you can see that the execution rate is maximum 2,000 per second in the standard one and over 100,000 in Express. supported state transition is 4,000 in standard and nearly unlimited in express. And I think there's also a limit of 1 million concurrent executions per, I don't know if it's per account or per per state receiver. Anyhow, these limits are pretty huge, and usually you won't hit them.
Yes, right.
No, when it fails, it usually fails completely. So you would have to restart it completely. And in case you have some steps that need to be that or that can be executed more than once, you will usually be need to be careful to be idempotent here. So imagine an order step function execution that starts with taking an order, then it takes the payment, then it fulfills it. Imagine that it fails in the fulfillment step. If you restart it, well, you will take the payment again. So you will need to make that step idempotent. That's actually maybe why one of the reasons you want to use a callback pattern for these kind of steps. So in this case, in my demo, I showed you how it would react if the the payment gateway is offline. So you would wait, step function would wait until it comes back up online, and it would continue the workflow. But yes, usually if it fails, step function please fails completely, and you would have to restart it from scratch.
We also have one more question.
Yep. Okay, best practice for error handling. Yeah, as I showed in the slides, there are two ways to handle errors. So one is retry. So that would help to cover transient errors. So maybe a common use case would be, I don't know, maybe DynamoDB throttling. So if you retry, usually maybe the second time it would succeed. But for non-transient errors, what you would normally want, well, depending on the use case, maybe you want to patch that error into something. So yeah, maybe back to the previous question and the example I gave, if there are some steps that fail, well, and previous steps have been executed already, so maybe you want to exactly roll back things. So maybe do a refund to the user, or maybe if you inserted something into DynamoDB, you will want to remove it, do some cleanup. Usually, that's kind of the use case you would do, the kind of things you would do in a catch from an error. Yes.
Awesome. We have, yeah, there was one more question.
Okay, if Lambda is there, why use step function? Well, the goal of step function is usually, or at least one of the benefits that I mentioned, is to break down complex workflows and complex business logic into different smaller pieces that are easier to build, debug, and maintain. So in the case of the order processing again, you could, if you wanted to, do everything in one single Lambda. So take the order, take the payment, fulfill it, send a notification to the user. But this is maybe bad for maybe two reasons. And the first one is that it breaks the single purpose principle of Lambda function. So one Lambda function should usually only do one thing, ideally. And the second reason that it makes everything a bit more complex, because suddenly everything is into your code, into one single Lambda. Maybe you have a bunch of if and conditions and for loops and whatever and whatnot. So breaking it down into different steps that are visually that you can visually see into the console, it really helps you to break down everything, debug, and understand immediately what goes wrong. Because if you go to this console in step function, and you open the execution, you will directly see what is in red, and you exactly know immediately what goes wrong. Then you can go into that Lambda. If it's Lambda, you can go into that Lambda's CloudWatch logs and see what happened exactly, and it's much easier to work with.
I think that's pretty much it. Those are the questions. Thank you so much, Vinay, for joining us early from Spain. And it was a lovely session, and I'm sure everybody was able to get started with step functions. And if there are any questions, please reach out to him on Twitter. He's pretty much active, and you can find him on LinkedIn as well. We will share the links in the chat section. Thank you so much, Vinay, once again for presenting at Serverless Saturdays.
Yeah, thanks for having me.
Thank you.
Thank you.
Thank you. Bye.
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 Okay, so I think we are now for the exciting time of the day. Okay.
Yes, so it is quiz time. So make sure you're registered on the Quizzer platform. I'll be posting the link again in this comment section. All right, so I've pasted it. You can register for the quiz. We'll wait for some time, but and meanwhile, I'll give you some rules, some do's and don'ts of the quiz. So, for a smooth experience on this platform, that is QuizUp, we recommend you to be on either Google Chrome or Safari. And please try not to refresh your screen. In case you get dropped out from the quiz, please join as soon as possible. And let's say if you do get dropped out and you join, you won't be allowed to answer the current question. However, you can play from the next question onwards. And we request you to be not on VPN, as that would affect your bandwidth. And that is pretty much all the do's and don'ts of the quiz. Okay, so we have 13 participants so far in the quiz. So we'll just wait for a minute. As it is a live quiz, it's better to wait. Meanwhile, tell your friends to join the quiz. It's an awesome opportunity to win $50 AWS credits. Also, let us know how you like today's Serverless Saturdays in the comment section. And if you have any inputs for us, all right, we have 14 participants now. So, shall we get started, Shoshit? All right. So, let's get started with the quiz. Uh, Before the quiz starts, I'll tell you how the quiz works. When the quiz starts, you'll see a question on your screen, and you'll see some four options. Out of them, you have to select the correct answer, and you will be given 30 seconds to select the correct answer. And after the timer is up, you'll see what was the correct answer and explanation for the same. That is it. It's that simple. I have joined, but it's not showing my name. There is echo. So make sure you stay in the quiz room and not in this live stream, as this live stream is also integrated in the quiz, or you will hear the echo. And uh, if your name is not showing, that means you haven't registered for the quiz. or you can try refreshing once.
Yes, and if you're live on both places, because this YouTube is streamed onto the quiz platform as well, you can probably mute the video stream in one place so that you don't get the echo.
Yes. Also, if you have opened the YouTube live stream in a different tab, make sure that the red light of the live is there and you are live with the video, or we might lose you. If it's not live, you can click on the live button and it will go live. Catch up with the current stream. Okay, so we have 16 participants. Yes, Indrajit, I see you. I think your name is showing. Okay, so let's get started with the quiz. The first question will soon be on your screen. Okay, so the time is up, and the correct answer to the question was a serverless state machine service, and 64% of the participants answered it correctly. Moving on to the second question. Awesome, so the time is up. And correct answer to this question is task, and you can see the explanation on the screen. Moving on to the third question.
Karthik, we can't hear you. Probably on mute.
Oh, sorry. Moving on to the fourth question. Thanks, Rushil. The time is up, and the correct answer to the question was the state fails as a whole. And you can refer to the explanation seen on the screen. Around 23% of you answered it correctly. Moving on to the fifth question.
Okay, let's see who's on the top of the leaderboard.
Yes. So on that leaderboard at first position we have Abhishek Wak. Then at the second position we have Lakshmi Kadali. And at the third position we have I think it's Richard. What's the ID? Vihas14786 at the rate RICHT.
Interesting name.
Yeah. So uh, with this moving, we will go to the next question. So the time is up, and you can see the correct answer on your screen. And you can also see the explanation for the same. Moving on to the next question.
Okay, we still have Abhishek leading. Yeah, Abhishek has a close contest with Lakshmi, and we have all of them are on 4 points.
And the time is up. And the correct answer was ASL. You can refer to the explanation seen on the screen. So on the leaderboard is changing, and on the live leaderboard, on the first position we have Vihas 14786, and Abhishek is at the second position, and the third we have Lakshmi Karali. Moving on to the next question. The time is up, and around 38% of the participants answered correctly. So just two questions to go, which decides who will ultimately top the leaderboard. And with this, we'll be moving to the second last question of the quiz.
Okay, Abhishek has fallen behind, and Vihas is leading.
And we have Mayank on the top three now. Moving on to the last question of this quiz. And the correct answer was yes. And the explanation can be seen on your screens. So, with this, we have come to an end with the quiz, but the leaderboard is still updating. It will take a minute or two to update it and to know who the final winner is for the last couple of questions. So, Sushil, shall we wait for a minute and see?
Yes,
Or, or
yes,
alternatively, we will reach out to the winner over email.
yes. We will reach out to the person on email, and we will share the AWS credit with the person. So let's wait for another minute. In the meantime, if anybody has any questions with respect to the sessions that we had today, or uh, uh, anything with respect to serverless Saturdays, if anybody here is interested in presenting at our serverless Saturdays, please reach out to any of us. You can reach out to Karthik, myself, or Dharmendra. We are easily accessible. You can find me on Twitter, and we'll be more than happy to have more people join us and share their experiences with the rest of the world. Okay. Section of AppSync without Amplify. Sure. So, Karthik, do we have the final results out?
I think so, yes. Or what we can do is, how about you guys can after some time, you can visit the quiz leaderboard and see for yourself who has won the challenge, the quiz, and we'll be reaching out to the top winner. So currently on the leaderboard at the first we have position we have Vihas 14786 at the rate RICSD. At second position we have Lakshmi, and at the third position we have Abhishek Wagh. So that is the current position. So yes, so we'll be reaching out to the quiz winner over email, and we'll be giving $50 AWS credit. So this was Serverless Saturdays, and we'll be having one more amazing session next month. So do join and get yourselves upskilled on serverless and AWS.
Yes.
Yes.
Thank you so much once again for everybody joining, and thanks to the speakers for an amazing session. Looking forward to hosting both of them again sometime on Serverless Saturdays, and looking forward to getting more experts on this platform to help you uh, get into serverless. Thank you so much, and hope you all have a great weekend. Stay safe. Thank you. Bye-bye.
Bye everyone. Have a great day ahead.